Hello everyone, and welcome to the Singly Linked List implementation lecture. In this lecture, we're going to be implementing a basic singly linked list. Remember, in a singly linked list, we have an ordered list of items as individual nodes that have pointers to other nodes. So as always, you have a Jupyter notebook with the code that we're going to go through. It's actually pretty simple in this case, and there's also some more discussion on pros and cons, which we'll get to later after implementing it. So let's go ahead and jump to the live code and implement this singly linked list. First thing I'm going to do is actually just create my node. So I'm going to say class node object, and this is a big part of doing any sort of linked list interview problem or question. Usually you're going to have to implement your own node class and use the different methods and attributes of that node class to further answer the question that's referring to a linked list. In this case, we're just implementing a singly linked list. Meaning, I'm going to take in just one attribute, value. I'll say self.value is equal to that value. So, for example, in the previous lectures, we saw examples of values being pointing to strings referring to airport codes. So we could use that later on. And since this is a singly linked list, I just care about the next node I'm pointing to. I'll leave it as none for right now. Alright, so we have this really basic class of a node, and we're going to use it to build out a linked list as a collection of nodes. I'll say A equals node with a value 1 to keep it simple, then B with a node of value 2, and then C as a node of value 3. Now, I want to actually link these nodes together. And to do that, I can just say A next node is equal to B. And similarly, I can say B next node is equal to C. And that's all there is to it. So we've already developed our own linked list. So I can go ahead and check out values from it. And I can also check out the nodes that are coming next. Meaning I could say a.nextNode, and I will actually just get a statement on an object class here, so node where it's being stored. But I could call the value of the next node, and that should get me the value of b, which in this case was 2. So if you run that, we get 2 out. Okay, that's really all there is to it. I hope that this implementation shows you how simple the idea of a linked list is. You just have a node in this case, and for a singly linked list, you just care about that node's value and then the next node that's coming up. You go ahead and create instances of those objects, and then you just assign what the next nodes are. And then you can call their values. As far as pros versus cons, what's nice about linked lists is that they have constant time insertions and deletions in any position. In comparison, arrays will always require linear or big O(n) time to do the same thing. Linked lists can also continue to expand without having to specify their size ahead of time. So try to remember our lectures on array sizing from the array sequence section of the course, where we talked about amortization and how we kept having to double that array size. Since linked lists are just collections of nodes, we can just keep inserting the nodes, and we don't have to worry about the lectures on dynamic arrays. Some cons to a linked list is to access an element in a linked list, you need to take OK time to go from the head of the list to the kth element. In contrast, arrays always have constant time operations to access elements of an array. These pros and cons are written out for you at the bottom of the singly linked list implementation lecture, and this is probably the main one here, that to access an element in a linked list, you need to take OK time to go from the head of the list to the kth element. In contrast, arrays always have constant time operations to access elements in an array. Definitely the main things to know here are this line of the pros versus this line of the cons. Essentially, if someone asks you in an interview, what are the pros and cons of using a linked list versus an array, you're really going to want to have these answers ready to go. Okay, hopefully the implementation was pretty simple. I know we went over the theory in the previous lecture and it might have seemed a little obscure, but now you can really see how easy it is to just implement a node set up a value, and set up a next node for a singly linked list. In the next lecture, we'll be discussing doubly linked lists, and after that, we'll actually implement one in Python. And it'll also be pretty simple, but we'll have to add certain attributes and methods to that node class. Okay, that's it, and I'll see you at the next lecture. Thank you, everyone.